Yeah, hi. Now I'm going to explain matrices, Karnataka board PU syllabus. In the previous video, I explained inverse trigonometric functions. That the weightage is 1 plus 2, 3 marks weightage. I cleared 1 mark and 2 mark, 3, all 1 mark and 2 mark questions. Now in this, the topic is matrices. The weightage is 1 plus 3 plus 5, total 9 marks. Now in this video I am going to explain all 1 mark questions. Maximum the possible 1 mark questions I am going to explain. All possible 1 mark questions. Next video I will do that all 3 marks questions. Third video 5 marks questions. At least if we concentrate daily around 20 minutes, 20 to 30 minutes if we concentrate, one part you can learn. Now the easy way I can explain that. Still if you want any particular help, in comment box let me know. Definitely I am ready to help you. Always my aim is to help everyone. Now look into the matrices. Here the questions, the 1 mark questions. First they will ask about the types of matrices. Generally they are asking about the types of matrices. You can see this. There is suppose define column matrix. If a matrix has only one column, then that is called column matrix. Only one column. We don't bother with number of rows. Just I give an example: 3 rows in one column. Sometimes the same question they ask like this. Suppose the given matrix Aij M by N is a column matrix. The given is a column matrix. You can see. The given is a column matrix, then what about n value? Then n is equal to 1, right? If A is M by N is a column matrix, then n is equal to 1. That was you can think. So define a row matrix. If a matrix A has only one row, then A is called row matrix. Correct. Row matrix. Now example A equal to 1 minus 4, 6, 1 by 3. Now you can observe, suppose the same thing. Matrix Aij M by N is a row matrix. Then M is equal to what about n value? So whenever it is a row matrix, then M is equal to 1. Correct, one row. N is any number of columns will be there, right? So only one row. So when this is a row matrix, M is equal to 1. When this is a column matrix, n is equal to 1. Remember. Next I will discuss about square matrix. Now you can see here in this square matrix, a matrix in which the number of rows is equal to the number of columns is said to be a square matrix. Example 1, 4, minus 2, 0. We can say order 2 because rows equal to column. Number of rows to number of column. This is order 3. This is called order 2. This is order 3. Suppose if they say A is equal to matrix Aij M by N is a square matrix. Then what do you write? Then M is equal to N. Again M is equal to N. I can also say this is order of M by M. When M is equal to this condition is a square matrix. Then when it is a square matrix, M should be equal to N. Then I can also say it is a square matrix of order M or square matrix of order N. Correct. It is a square matrix, then definitely M should be equal to N. That we can say like that. You can see that now define a diagonal matrix. A square matrix is said to be a diagonal matrix if all its non-diagonal elements are 0. Whenever all its non-diagonal elements are 0, then it is called diagonal matrix. See here order 1, this is order 2, this is order 3 of diagonal matrices. I can also discuss suppose they are given A equal to matrix Aij M by M is a diagonal matrix. Suppose if it is a diagonal matrix, I can say, suppose when I am saying it is a diagonal matrix, is said to be a diagonal, I can say if it is a diagonal matrix, then definitely you can observe here Aij equal to 0 when I not equal to j. Whenever I not equal to Aij equal to 0. A mean is a diagonal matrix, then Aij equal to 0 when I not equal to j. I can also, it is a set to be a diagonal matrix. Aij equal to 0 when I not equal to j. Now I can define this next scalar matrix. Okay, see, define a scalar matrix. A diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. Whenever diagonal elements are equal, we can say that is a scalar matrix. That should be a diagonal matrix. That means it's a square matrix only. So here 4 here, only this one 4 4. Diagonal elements should be equal, other elements should be 0. I can also say, suppose A is equal to matrix Aij m by m is said to be a scalar matrix. Is said to be a scalar matrix if Aij equal, you can see here, A equal to 0 when I not equal to j equal to some k, I equal to j. Here with some constant k. For some constant k, when I equal to j, it will be k. This diagonal should be equal. This also I can define scalar matrix. Now I will define identity matrix. Okay, so when I am talking about define an identity matrix. So define identity matrix means a square matrix in which all the elements in the diagonal are all 1 and the rest are all 0. So you can see that diagonal should be 1, diagonal should be 1, diagonal should be 1. The rest are all 0. That is called identity matrix. It is denoted by I. If it is order 1, I1, order 2, I2, order 3, I3, order n is In we can write. I can also say, suppose A is equal to Aij n by n is an identity matrix. Suppose if it is an identity matrix, then definitely we can write. You can say, if it is an identity matrix, here again, if it is an identity matrix, when can I say this identity matrix? If I can, if Ij equal to, I can express Ij equal to 1, I can say when I equal to j, 0 when I not equal to j, right? Aij value. 1 when I equal to 0, when I not equal to j, we can mention like this. So related to is an whenever it is an identity matrix, we can express if Aij equal to 1, I equal to j, 0 if I not equal to j. This also we can express. Now I will discuss about the zero matrix. So if they ask the problems related to this order, a matrix has 8 elements. Then what are the possible orders it can have? You can start very simple, we can start this. You can think the order of this 8 means you write 1 by 8. I can write 2 by 4, 4 by 2. And the product should be 8, right? 8 by 1. So this is writing into only, but you can write it is written as 1 by 8, 2 by 4, 4 by 2, 8 by 1. Correct. Now coming to this one. It has 24 elements. What are the possible orders it can have? When you are talking in this case, 24, you can write 1 by 24, 2 by 12, 3 by 8, 4 by 6, 6 by 4. You can write 6 by 4, 8 by 3, 8 by 3, 12 by 2, and 20 by 1. The possible reverse 24 by 1. Coming to 18 elements, when they are talking 18, you can write 1 by 18, 2 by 9, 3 by 6. You can write 6 by 3. Correct. Now again you can write 9 by 2, 18 by 1. So these are the possible orders it can have. Suppose now if they change, we have, suppose they mention 13 elements. They change the question now. This is question number 10. If it is 13 elements, When they're talking 13 elements, you can think about order. 13 is a prime number, right? We will get 1 by 13, 13 by 1, only this. Suppose it has only 5 elements. If it has only 5 elements, think about question number 11. If it is 5 elements, what are the possible orders it can be have? So 5 is a prime number. Again, the possible here 1 by 5, 5 by 1. This is the possible orders. Right? Now we'll discuss about the next question. We'll discuss the next problem. You can see in this problem that you find the number of all possible matrices of order 3 by 3, each entry 0 or 1. So this matrix having 9 entries are there. So if we consider 9 entries with 3 by 3, 9 elements will be there. 1, 2, 3, 4, 5, 6, 7, 8, 9 entries are there. Each entry either 0 or 1. So 2 ways I can do this, right? By fundamental principle of multiplication. 2 power 9. So 5, 12. That will be your required answer. 5, 12. You can see that they are asking this one 2 by 2 matrix. That means 2 by 2 matrix means you get A11, A12, A21, A22, right? So follow the suffixes 1 plus 1, 1 plus 1, 2 square by 4 by 2, it will be 2. Right, A12, 1 plus 2, 3, 3 square by 9 by 2, correct? Same thing here, A21, 2, 3 square 9 by 2. 2 plus 2, 4, 4 square 16 by 2, 8. So that will be your answer. 2, 9 by 2, 9 by 2, 8. Coming to this one, yeah, easy. When you are talking this problem again, A11, A12, A21, A22, right? Just think this will be easy. Substitute. This is I and J both are same 1 by 1, 1. This is 1 by 2. Here you will get 2 by 1, 2 only, right? This is 2 by 2, 1. It comes 1, 1 by 2, 2, 1, it will come right. Now coming to this, I plus j by 2 whole square. If you take this one, in this case you can consider the required answer A11, A12, A21, A22 should be equal to 1 plus 2. You will get 3. 3 square, you will get 9 by 2. Correct, the result will be 9 by 2. Very good. Again, A12, 1 plus 4, 5. 5 square, 25 by 2. A21. A21 is 2 plus 2, 4. 4 square, 16 by 2. It will be 8. Next, the given A22, right. A22 means, you can see 22 means 2 plus, we will get 2 is 4 plus 2, 6. 36 by 2, 18. That is the required matrix, right? So I can write this was the required matrix. I will do the next problem. See, in this they are asking 3 by 4 matrix. A11, A12, A13, A14, 2, 2, 2, 2, 3, 2, 4, A31, A32, A33, A34. Substitute the suffix here. You can substitute this here. Mod is there, modulus is there. Minus 3 plus 1, minus 2 by 2, it will come 1. 1, 2 if I substitute here. Minus 3 plus 2, minus 3 plus 2, you will get 1, 1 by 2. If it is 1, 3, if we substitute minus 3 plus 0, it will be 0, right? If it is 1, 4, substitute the values in this 1, 4, minus 3 plus 4, you will get minus 3 plus 1, you will get 1 by 2. Like this I can find first row I can find. Next I can this first row. Second row I will find now. You can see second 2, 1. If we substitute 2, 1, minus 6 plus 1, it will be 5 by 2. A22, minus 6 plus 2, 4 by 2, it will be 2. A23, minus 6 plus 3, 3 by 2. You will get 2, 4, minus 6 plus 4, 2 by 2, 1. That will be second row. 5 by 2, 2, 3 by 2, 1. You can take A31, minus 9 plus 1, 8 by 2, it will be 4. A32, minus 9 plus 2, 7 by 2. 8, 3, 3. Minus 9 plus 6 by 2, 3. 3, 4. Minus 9 plus 4, 5 by 2. Just substitute the suffix here, you can find this. Correct. Similarly, then you can think ai is j equal to 2i minus j. That's also we can discuss about that. So this is the first one. This is override. This is related to this. Now I am going to do this problem. And I am going to do this one. This override. Now I will do this problem. Same thing. The order will be the same thing, right? They are asking 3 by 4. I want this one. I completed this one. Yeah, is j. And after going to substitute the values 2i minus j. If I take 2i, you can think about 2i minus j. So you will get 2 minus 1. It will be 1. 2i minus j. 1, 2. So 1, 2 is 2 minus 2, 0. Just follow this one, substitute the values. If you get 1, 0, you will get minus 1, minus 2. Why? Because 2 minus 3. Next one 2 minus 4, minus 2. Next one 2, 1. 4 minus 1, 3. 2, 2. 4 minus 2, 2. 2, 3. 4 minus 3, 1. 2, 4. 4 minus 4, 0. The second row will be 3, 2, 1, 0, right. Next one 3, 1. 6 minus 1, 5. 3, 2. 6 minus 2, 4. And this one 3, 3. 6 minus 3, 3. And 3, 4. 6 minus 4, it will be 2. 5, 4, 3, 2. So this is this problem. So just substitute the values. The suffix you can substitute here. You will get the answer. Now I will do the next problem. Like similarly how I have done the previous one, the same model. 1 by 2 mod I minus 3j. We can substitute 1 minus 3. Minus 2 by 2 mod is a 1. You will get 1, 2. 1 minus 6. You will get 5 by 2. 1, 5 by 2. Because only two columns are there. Well, first row is this one. Second we substitute 2, 1. 2 will get 2 minus 3. You get 1 by 2. 1 by 2. 2, 2. You will get 2 minus 6. 4 by 2 will be 2. 3, 1. You will get 3 minus 3. It will be 0, right. And this 3, 2. 3 minus, you will get 6. You get 3 by 2. Matrix. That will be the answer here. Now I will explain next problem. Now, the simple problem that these two are equal. When two matrices are equal, the corresponding limit should be equal. If we compare, I can write x is equal to 1, y is equal to 4, and z is equal to 3. Now we will do the next problem. So these are simple problems. They may ask for 1 mark. They are given a minus b, ab. If it is a minus b, you can check the difference of this. 2 minus 1. Again it 4 minus corresponding elements. 3 minus of minus plus 2. 2 minus 5. 1. You will get 1, 1. And 5 minus 3. If it is AB, the product. So we will get 2, 4, 3, 2, 1, 3 minus 2, 5. I can multiply this first row with first column, right? We will get 2 minus 8, 6, first row with the second column, 2, 3, 6, 4, 5, 20. Again, second row with first column, 3 ones are 3, 2 2's minus 4. Again, second row with second column, 3 into 3, 9, plus 2 plus 5, 10. If you multiply two matrices, when you multiply two matrices, we can see here the number of columns of first one should be equal to number of rows of second one. First row with first column, 2 into 1, 2. You get plus 4 into minus 2, minus 8. First row with the second column, 2 into 3, plus 4 into 5. Now here, second row with first column, 3 into 1, plus 2 into minus 2. Next, second row with second column, 3 into 3, plus 2 into 5. This will be minus 6, 26, you get minus 1, 19. The product AB. Anyone they may ask for 1 mark, find A minus B, or sometimes A plus B, or sometimes AB. They may ask, just give an idea of this one. Again, check if I take AB now. AB 0, minus 1, 0, 2, 3, 5, 0. Multiply this. First row with first column 0 only, right? First row with second column 0. Second row with first column 0. Everything 0. It's a 0 matrix. The product is 0 matrix, but either of them, you see, either of them is not a 0 matrix. Both are non-zero matrices, but the product is 0 matrix. Next one, I will discuss next one. So see, in this problem, most important, this one model is important. When you are multiplying this 1, 2, 3, so this is matrix 1, 2, 3 and 2, 3, 4. So this is 1 by 3 and this is 3 by 1. No, sorry, this is 3 by 1. 3 rows, 1 column. This is 1 row, 3 columns, 1 by 3. To multiply, it comes 3 by 3. The product will be 3 by 3, but dot is 3 by 3. So you can see first row with first column, you get only 2. First row, second column, you get 3, 4. First row with first column, first row with second, first column, second column, third column. With 2, 2 2s 4, 2 3s 6, 2 4s 8. This one 3 2 6, 3 3s 9, 3 4s 12. This is 3 by 3. This is the required matrix of order 3 by 3. When they are talking about define transpose of a matrix, transpose means if interchange rows and columns of the given matrix, that is called transpose of the matrix. Let it be an M by N matrix. The matrix is obtained by interchanging the rows and columns. By interchanging the rows and columns of the given matrix is called transpose of A. It is denoted by A dash or A power T. So for example, A is equal to given 1, 2, 4, 1, 2, 3, 4, 5, 6. You can see the order is, you can write 2 by 3. The transpose, if we take, the order should become 1, 2, 3. First row will become first column, second row will be second column. So the order will change into 3 by 2. 2 by 3 rows, 2 columns. 2 by 3 will become 3 by 2. And also sometimes they may ask here, so what is the A dash whole dash? This will be A. They may ask this one sometime. And sometimes they can also ask A plus B whole dash. So what about this one? A dash plus B dash. These are the I am discussing here. These are the properties I am discussing, right? Only the properties just I am discussing. What is A dash whole dash is A. A plus B whole dash. A dash plus B dash. Transpose, right? Sometimes they may ask that, but just you remember that. What is the property of that? If they ask, suppose K A whole dash. If it is K A whole dash means I can write K into A dash. There is no change. K into A dash. The properties. Suppose if AB whole dash, this will be B dash into A dash. Transpose. AB whole dash could be B dash into A dash. So this is a possible question from some questions. What I am discussing now. Okay, I will discuss now symmetric matrix. When I am talking about the symmetric matrix, a square matrix A is said to be symmetric if A transpose is equal to A. An example, when they are asking example, you can write diagonal of any elements I can write. Now you can see here, suppose when they are talking about this one, this is the diagonal elements, right? 1, 5, 6. Suppose if I write here, you can see here, if I write 4 here, I will write 4 here. If it is minus 1, I will write the same element, I should write minus 1. This is suppose you write 0, this is also write 0. Like these two should be same, these two should be same, these two should be same. This should be definitely against, this is called symmetric matrix. You can verify. Take the transpose of this, do the same thing. There is no change. 1 4 0, 1 4 0. 4 5 minus 1, 4 5 minus 1. There is no change. If you change rows into columns, there is no change in the matrix. Then that is called transpose of the matrix, right? This is transpose example. This matrix is always I can find. This is symmetric matrix. Transpose, same, both are A dash equal to A. If we change rows and columns, it gives the same matrix. Then we get this is symmetric matrix. Remember, sometimes if they give for like, they will give like this 1a0, they will give like this 1a0, 4 5 minus 1, 0 minus 1 6. Since it, suppose if it is a symmetric matrix, what is the value of a? These two should be same, right? So a is equal to 4. Always remember, these two should be same. These two should be same, right? And this one should be same, right? These elements should be same. Correct. They will give an unknown value here. Then what is the value of a? A equal to 4. Now when they are talking about skew symmetric, define skew symmetric matrix. A square matrix A is said to be skew symmetric if A transpose is equal to minus A. If A transpose minus A, then the matrix is said to be skew symmetric. If A transpose minus A. So whenever A transpose minus A, then you can see the example A is equal to, you can write the principal diagonal should be zeros only. If it, you can see, I can write if it is 4, this will be minus 4. I can write. If it is 2 here, this will be minus 2. If it is minus 1, this will be 1. So this is known as skew symmetric matrix. Standard for example, you can think if they give like 0, E, F, I can write this one. Minus E, 0, some G I can write. So this one F, G and 0, right? Like this I can write. If we consider opposite sign symbol, this is minus minus. Should be careful opposite symbol. Suppose if you write minus, this is plus. Minus E, minus F, minus G, minus G. Opposite symbol, always. This one. If it is minus, this will be E. If it is minus, this will be F. Like this you can write. So these examples. Sometimes they may give problem for 1 mark. Like this, they will ask any one unknown value. You can find easily. You can find that. So now with this, I have completed almost. I covered all the 1 mark problems related to this. Maximum, I will try my level best to cover all the 1 mark questions. The next video, I will try to cover the 2 mark, 3 marks, and 3 marks. I will do that. 3 marks around, we have around 10 to 12 problems will be there. If we solve that, definitely we will be able to get 3 marks. 5 marks also around 10 problems. I will do that. Thank you. See you in the next video.